Welcome to today's session on embedded systems. Today we are going to discuss about the software architecture of embedded systems. As we know that the embedded system is a package of hardware and software, it is essential to discuss every elements in the software architecture. When we take an embedded system, it has a hardware, and for the hardware to function properly, we need a software. That needs an operating system and an application software. So, for example, in the real-time applications, in the day-to-day basis, we use a mobile phone, which is an example for real-time application. So, what are the OS that we use in a mobile phone? So we use Android OS, we use BlackBerry, we use iPhone, we use Symbian OS, Palm OS, etc. So what is an OS? An OS is nothing but a small piece of software that the user uses to interact with the hardware. When the system is being booted, the OS gets loaded to the RAM. The OS performs several jobs that we call as tasks. So when an OS performs multiple tasks, all these multiple tasks has to be managed by the operating system. Hence, a OS is nothing but it has a hardware and then in order to make it function, we need a operating system OS and then an application software. So before going in detail about the architecture of the operating system, let us discuss about the categories of operating system. The categories of operating system are single tasking versus multitasking. Single tasking. In single tasking OS, only one task is carried out at a time. For example, if we take a DOS operating system, we have to give one command for execution. Only if we exit from that particular task, we can go for the next task. That is an example of single tasking OS. The next is multitasking OS. In multitasking OS, multiple tasks can be run simultaneously. For example, if we take a Windows operating system, at the same time we can perform multiple tasks. For example, one task could be a file sharing and another task could be I can connect to the internet. One task should be file sharing and the task should be I can connect to internet and I can download a video. At the same time I can work on Excel. So similarly I can work with multiple tasks. The next category is single user OS versus multi-user OS. In single user OS, only one user can use the system at a time. Example, Windows. In multi-user OS, multiple users can share the system simultaneously on time slice basis or time division multiplexing. The best example would be Unix OS, wherein every user feels that he is using the entire OS. The next category is called command driven OS or GUI based OS. In the command driven OS, as we discussed earlier in the DOS, we have for every task we need to operate, we have to give a command. For example, it could be a copy or delete or replace. So each and every command or a task to be executed has to be given through command. So example is DOS. And the next is called GUI instructions through mouse clicks. For example, if we take a Windows operating system, so whatever task we perform, we use a mouse to click. So for example, if you click on File and then click on Open and then click on Save, click on Write, click on Delete. So these operations are being done based on GUI instructions. So these come under the category of command-driven OS. GUI-based OS. As we are discussing about the OS, we need to know what are all the non-real-time OS, real-time OS and the mobile handle OS. So non-real-time OS will have a smaller footprint. So footprint is a place where it is a memory where the OS is being loaded. Where OS is loaded. And this non-real-time embedded system OS are not suitable for hard real-time applications. Example for this could be embedded Linux, embedded NT. On the other hand, real-time OS are suitable for hard real-time applications. Example could be Neutrino, VSWorks, RT Linux, Micro C. As we discussed, the mobile handheld OS could be used for mobile devices. Example, Palm OS and Symbian OS. So in order to meet the OS requirements, what are the criteria we should satisfy? So OS requirements first could be a reliability. The OS should be 99.9% reliable. It has to work for continuous hours without any software conflict. And next is multitasking. Mostly all the embedded systems work on multitasking. So when we go for multitasking, each task should be carried out without any delay to meet the real-time application requirements. And the OS should have small footprint. Since the embedded systems does not have any secondary storage, the memory is very small. So it is the place of memory where the OS is getting loaded. So it should be small. Embedded system does not support diskless systems. It does not have any secondary storage or a CD-ROM, any accessories. So it should support diskless systems in the fashion it has only flash memory. And the embedded system should be portable. The embedded system should have a scalability. For example, if I design a microcontroller for 8 bits, so in case if I want to use it for 32 or 60-bit microcontroller, it should be scalable. The OS should support for standard APIs, that is the standard IEEE standards like IEEE 802.15, 802.12. For different applications, it should support the standard of API. The services provided by the operating system are process and task management, memory management, I/O management including memory, managing the file system, providing services to application, providing a user interface so that the user need not be concerned about the underlying hardware details. Now let us come to the architecture of the embedded system. So the embedded system, when we look into the architecture, the heart of the OS is the kernel. And it includes libraries, device manager, file system and the communication software. So above that we have the application programming interface, nothing but your API. Then comes your application software. So as we discussed, the heart of the OS is the kernel. It manages the task to achieve the desired performance of the embedded system. It performs managing tasks such as scheduling and provide inter-task communication. It provides memory management, device management, interrupt handling, and time management services. The next is the device manager, which manages the I/O devices through the interrupt and device drivers. Device drives provide the interface between the application and the hardware. Next is the communication protocol software. If the system has to be network enabled, then it has to support any of the TCP/IP protocols or Ethernet or USB, Wi-Fi, etc. And this communication protocol software should be TCP integrated with the OS. And the libraries or C, C++ libraries in the object code, which can be used through API calls. So the file system, since the embedded system do not have secondary storage, programs are stored in ROM. In case if a file system is required, a small file system is developed with the flash memory. So now we have discussed about the libraries, kernels, device manager, file system and communication software. Next is we need to discuss about the application software. Hence, an application software is developed used by any standard APIs. The development tool that provides a function call to access OS services. It can be to create, suspend and delete a task, to do task scheduling for real-time requirements, to facilitate inter-task communication and synchronization between tasks, to initiate, increment and reset conditions to keep track of time, to allocate and free the memory, to access I/O devices, to access communication protocol stack. Using these function calls, application software is written together with the OS and communication software and then converted to a relocatable image. It is stored in the EEPROM or EEPROM, etc. On power on, it is transferred to the RAM and then executed.